FastMCP3's asynchronous client-server interaction model employs context-managed resource handling to streamline paginated data retrieval. The framework's client class abstracts low-level pagination mechanics, presenting a unified interface for fetching complete tool inventories through automatic cursor-based iteration. We're about to examine how the client initializes a connection, executes a paginated list operation, and aggregates results transparently, all while maintaining clean resource lifecycle management through Python's Async context protocol. The code demonstrates the framework's core pattern for handling large result sets without exposing implementation complexity to the application layer. From FastMCP import client. Async with client-server as client. Hash returns all 200 tools, fetching pages automatically. Tools equals await client list tools. Print total tools. Len tools hash 200. This code demonstrates FastMCP3's pagination handling through the client class. The list tools method abstracts away the complexity of paginated responses, automatically fetching all pages and returning a complete list of tools. This convenience method handles cursor-based pagination internally, making it appear as a single operation to the developer. The design choice to hide pagination complexity behind a simple interface follows the principle of progressive disclosure. For most use cases where you need all tools, this approach is optimal as it reduces boilerplate code. The client handles the cursor field automatically, which is an opaque base 64 encoded string that tracks pagination state according to MCP specification. However, this abstraction comes with trade-offs. While convenient, it fetches all results into memory at once, which may not be suitable for memory-constrained environments or when processing large datasets incrementally. The framework provides lower-level MCP methods for such scenarios, allowing manual cursor handling when needed. This dual approach gives developers flexibility while maintaining simplicity for common cases. Let's break it down line by line. From FastMCP import client. Imports the client class from the FastMCP module, making it available for creating FastMCP client instances in the current scope. Async with client-server as client. Establishes an asynchronous context manager for a client connection to the specified server. The async with statement ensures proper resource management, automatically handling connection, setup, and teardown. The client instance is bound to the variable client for use within the context block. Hash returns all 200 tools, fetching pages automatically. Tools equals await client list tools. Calls the list tools method on the client object asynchronously, retrieving all 200 available tools with automatic pagination handling, then assigns the complete collection to the tools variable. The await keyword indicates this is an asynchronous operation that will yield control until the tools are fully fetched. Print total tools. Len tools hash 200. Prints a formatted string that displays the text total tools, followed by the length of the tools collection, with a comment indicating the expected output is 200. This is a simple debug or logging statement that outputs the count of items in the tools variable to the console. FastMCP3's client-server interaction model demonstrates a clean abstraction of pagination complexity through the client class leveraging Python's Async context protocol for resource management. The async with statement establishes a connection, while list tools handles cursor-based pagination transparently, returning a complete dataset as if it were a single operation. This design follows progressive disclosure, hiding implementation details for common use cases while providing lower-level methods for scenarios requiring manual cursor control. The trade-off is clear: convenience and simplicity for most applications, with the flexibility to opt into more granular control when needed. The framework's dual approach ensures developers can focus on application logic while maintaining efficiency for both typical and edge cases.
The cursor whispers to the server, and tools spill forth endless, yet always just one page at a time.